Hello everyone, sorry for the delay due to some unexplainable reasons. But now Team Kalpana is back again from IIT KGP. So let's get started with our first video log. So let us start with the concepts behind our first preliminary design. So this was our initial model. So this was a cylindrical design having a circular cross section, and it was consisting of three modules. One was the sensor module from here to here, and there was one dust accumulation rate analyzer, this blue color portion you can see, and down to it there was electronics and computer module. So this complete system was enclosed by a Faraday cage to avoid any kind of external noise, and the whole module was again coated with thermal protection layer. Now this sensing module was having three units. One was the DFR unit, which is deflection field region. I'll explain it. And there were two DTS units, DTS 1 and DTS 2. What is DTS? DTS is actually the dust trajectory sensor. So this dust trajectory sensor, each of these were having 4 layers of electrodes, where these were stainless steel wires which were sensing the charge and the trajectory as well as the velocity of any charge particle entering into the instrument. Now this deflection field region was used for measuring the mass of the charge. This is our sketch which was taken from some literature. Now this is the first DTS unit and the second DTS unit. So these are the layers of the electrodes, and these were this is the electrodes of DFR unit. Now any charge particle which enters into it, the direction and as well as the velocity is being detected by the first DTS unit and later by the second DTS unit. Now these electrodes of DFR unit is having different electric potential in the consecutive electrodes. One with plus 5 kilovolt and second one is minus 5 kilovolt. So any positively charged particle is deflected away from the positive charged electrode, and hence the deflection is measured from the difference between the trajectories of the two DTS units. Now this is the whole idea behind our instrument and sensing the parameters of any charged particle. So this is our sketch of the design. So each layer of DTS was having 4 layers of electrodes. So they were coming out like this. Suppose we are using 5 electrodes per layer. Now we have to connect one end of each electrode to a amplifier unit, which will take the signal from the induced charge signal through the electrode, and it will amplify, and then it will give it back to the electronics module, where we will have our onboard computer which will take it as its input, and it will store the data or whatever post processing we need to do. But to accommodate these amplifying circuits, we need some space first. Second thing is, there were some scaling issues as per the similarity rule by the literature we are following. So if we go through that, so the model they have used, if we need to scale it down, we have to follow some similarity rule. So that's why we have modified some changes, we have done some changes in our physical dimensions of our model, but the overall volume of the model we have kept constant and the same, that is 116 mm into pi 32.5 whole square mm square. So this volume we have kept constant, but we have changed the physical dimensions of the model. So it will look something like this now. So we have made our dust sensing module like this, where we have the dimension of the sensor module 40 cross 40, 40 cross 40 cross section, and the length would be 60 mm. This is 40 mm and this is 40 mm. This is 60 mm, and the charge sensing amplifier unit will be accommodated in the rest 2 centimeter of the space from this axis. Suppose this is x axis and this is y axis, so we can have 2 centimeter this side and 2 centimeter this side, and total this box cross section will be 6 cross 6 centimeter. 6 cross 6 centimeter, yeah, correct. And the height of the box would be 6 centimeter. Now we can accommodate our dust accumulator unit and electronics computer module in this 8 cross 8 cross section module here, which will have a height of only 25 mm, and so here we are constrained to the overall volume, and we are not exceeding it. And now we are doing some simulation work. So let me tell you what are the steps we are following. We had already mentioned it in our abstract while submitting it in last August. So first is our analytical process, which we have already finished. Second is simulation, or you can say numerical solutions, which we are doing now. We are currently onto this. Third thing is experimental, which we will start very soon due to time issues. We have not started till now, but we have ordered all our instruments, parts, electronics. We have ordered everything. We need to assemble them, we have to check, we have to validate data, the simulation analytical data with the experimental things. If any changes required, we will do accordingly, and we will get all the updates very soon. And thank you.